Hi chums, welcome for today's video. So today we are going to see Ohm's law and resistance. So first let us recall what is electric current and potential difference, and let's start going to the video. So first is electric current. So what is electric current? It is the rate of flow of electric charge. So the formula is I is equal to Q by T. Its SI unit is ampere, and ammeter is used to measure the electric current. Next is the potential difference. So what is the potential difference? The work done in moving a unit charge from one point to the other. So the formula is V is equal to W by Q. Its SI unit is volt, and voltmeter is used to measure the potential difference. So in an electrical circuit, this ammeter is connected in series and voltmeter is connected in parallel. So you will tell me why ammeter in series and voltmeter in parallel in the comment section. So now next we are introducing a new one called resistance. So what is this resistance? It is the opposition of the flow of charges. That is, when the current is flowing, this resistance is acting in opposite direction to oppose the flow of charges. So we will learn about resistance very soon. So now we will see about Ohm's law. So in 1827, George Simon Ohm gave the relation between the voltage, that is potential difference, and the current. So now let us see what is Ohm's law. Ohm's law states that the current that is flowing through a conductor is directly proportional to the potential difference applied across its end, provided the temperature is constant. That is, at constant temperature, the value of the potential difference as well as the value of the current will always be directly proportional. Means when the potential difference value increases, then the current value also increases. So V is proportional to I. In physics, in order to remove the proportionality symbol, we introduce a constant. So here the ratio of V by I is said to be constant. So this constant is here R. So R is the resistance of the conductor, which is known as the electrical resistance. So it is also an electrical quantity which measures how the device or the material reduces the electric current flow through it. That is, in simple words, it is the opposition of the flow of electrical charges. So the SI unit of resistance is ohm. Now let us see an analogy to understand the relation between voltage, current and the resistance. When you ride a bicycle, when you pedal it very fast, the movement of the cycle will be fast, and when you pedal it little slow, the movement of the cycle will also be slow. Now the pedaling is the voltage and the movement of the cycle is the current, which is directly proportional to each other. The resistance is the air that is flowing in the opposite direction to the movement of the cycle. So when the air is flowing, even when you pedal it very fast, it opposes the cycle to move very fast. The same thing happens in an electrical circuit also. The voltage always encourages the movement of the charge from one terminal to the other terminal, whereas the resistance always discourages it. So how this is actually happening? For an electron, that is the so-called free electron, the journey from one terminal to the other terminal is not a direct route, but the electrons takes a zigzag path that results from countless collision with fixed atoms within the conducting material. That is, the electron, when it is moving, it dashes with the other ions present in the conductor. So due to this, there is a resistance, there is an opposition to the movement of the charges, and this we call it as the resistance. So now mathematical relationship of Ohm's law. So our resistance is connected to a battery and it is connected with an ammeter in series, and the voltmeter is connected in parallel with that of the resistor. So now we know the relation V is equal to IR, where V is the voltage and is expressed in volts. R is resistance and is expressed in ohm, and I is current which is expressed in amps. Now you see the beauty here. All the second letter of the units constitute of Ohm's letter. It's very simple and easy to solve the problems related to the Ohm's law if you remember the Ohm's law triangle. So Ohm's law triangle is nothing but the one side, that is horizontal, the top corner of the triangle is V, the left side corner is I, and the right side corner is R. If any of the two quantities are known, it is possible to find out the other unknown quantity. So the V is divided by I and V is divided by R, where I and R to be multiplied. So using this, let us now solve the problem. So now in the first case, when V is asked and I and R value are given, the formula will be V is equal to IR. In the second case, VIR, when I is asked and V and R is given, I is equal to V divided by R. And in the third case, when the resistance is not known and V and I is given, the formula will be R is equal to V by I. So that's it. It's very easy. Only these three formulas we are going to use in the calculation now. So in the first case, let us now consider the first example. That is, the V is given as 10 voltage and R value is given to be 500 ohm. Now what is asked? I is asked. So now which formula we have to use in these three? The second one. So I is equal to V by R. The value of V is 10 volt and the R value is 500. So when we divide 1 by 50, the answer will be 0.02 ampere. So the second example, in similar way, it is possible to use Ohm's law to find out the resistance also. So in this example, we have voltage as 10 volts and the current is 0.1 ampere. So now which formula we have to use? R is equal to V by I. So R is equal to V by I, V is 10 and I is 0.1. So the answer is 100 ohm. And finally, the other combination is that the resistance is given as 250 ohm. The current is given as 0.1 ampere. So now what we have to find? Yes, it's correct. We have to find out the voltage, which is V is equal to I into R. So V is equal to I value is 0.1 into 250, which is 25 volt. While plotting the values of voltage and the current in the graph, a linear curve was noticed. That is, straight line was noticed, which means that when the voltage is increased, the current also is increased, whereas when the resistance is high, the current is lowered, and vice versa. Not all the components are ohmic components, that is, not for all the components we don't get a straight line. There are also non-ohmic components like semiconductor, diode, etc., where we get a curve like this. Here you can see the picture. In the first picture you can see there is no resistor connected to the circuit, and in the second the resistor is connected. And you can also see the difference in the glowing of the bulb. So resistance is the hindrance to the flow of charges. So in order that the current can be limited in a particular circuit, a component known as a resistor may be used. So resistor come in variety of forms, from large wired components to the small. So let us learn about the resistors and the factor affecting the resistance in the next video. So that's all for today's session. So prepare well, go through the videos again and again and try to understand the concept. If you have any doubt, feel free to ask me. Thank you.